Hello everyone. In this video, we are going to dive into physics and measurements. Topics that we are going to focus on are units and dimensions. So let's begin. In mechanics, there are three fundamental quantities: length, mass, and time. And these quantities are accompanied by their respective units. The internationally recognized system of units, also known as SI units, are globally accepted. Here, SI unit of length is meters, mass is kilograms, and time is seconds. All other quantities in mechanics are expressed in terms of these fundamental quantities. For example, force, which has an SI unit of newtons, can be expressed as kilogram times meter over second square. In addition to this, when defining quantities, we use prefixes along with SI units. Here is a table that shows power of 10 and, and its prefixes along with their abbreviations. These are used in unit conversions. For instance, if we want to convert seconds to nanoseconds, we use this table to create the conversion factor. That is, 10 to the power negative 9 seconds equals 1 nanosecond. The power goes with the base unit, which in this case is seconds. This is a very important concept as it is one of the most commonly made mistakes. Let's do an example. Let's convert 25,000 meters to kilometer. So unit conversion simply change the unit while keeping the quantity constant. So mathematically, it can be represented by multiplying by 1. And that's the concept that we're going to use here. We begin with what is given to us, which is 25,000 meters. Then multiply this by a ratio. This ratio is the unit conversion factor. And this comes from the table. Since we are converting meters to kilometers from the table, we can find that 10 to the power of 3 meters equals 1 kilometer. Once again, the power goes with the base unit, which in this case is meters. And back to the ratio. In the numerator goes the unit that we want. We want kilometers. And the unit that we have goes in the denominator, which is meters. And this is because we can cancel out the units and we remain with the unit that we want. So now, using this, we can make this conversion factor, we can make this ratio equal to 1. Doing the calculation, it gives us 25 kilometers. Let's do one more example. Let's convert 15 inches to centimeter. Here we are converting customary units to metric unit. And we have some converting factor. And since we are not given a direct conversion from inches to centimeter, we need to do two steps. First, we convert inches to meter and then meters to centimeter. Following the same steps, we begin with what we have, which is 15 inches, and then multiplied by a ratio that converts inches to meter, and then another ratio that converts meters to centimeters. And so, once again, in the numerator goes the unit that we want, which is meter, and inches goes in the denominator. Here, centimeter goes in the numerator and meter goes in the denominator. And using this conversion factor, we can write this ratio. And from the table, since we are converting centimeters to meters, which is 10 to the power of negative 2 meters equals 1 centimeter. And after doing the calculation, we get this equals to 38.1 centimeter. Now let's move on to dimensions. Unlike units, which indicate quantities, dimensions describe what's being measured. Here we have a table with dimension and SI unit for area, volume, speed, and acceleration. Let's see how dimensions are obtained. So for example, for area, let's take area of a triangle, which is equals to 1/2 times base times height. In dimension, we ignore the number. Here, both base and height are length. And dimensions are, are mentioned in square brackets. So, dimension of area would be length times length, which is length square. Similarly, for speed, which is distance over time, the dimensions would be distance is just length between 2 points, and time it's time. So the dimension for speed is length over time. Dimensions are used for dimensional analysis. Since all derived equations are dimensionally homogeneous, meaning that each terms in every equation separated by addition or subtraction has the same dimensions on both sides of the equations. So let's do an example. V equals to A. This is one of the most common equation in this course. So for doing dimensional analysis, we start with left hand side. which is the velocity term. Here, dimension for velocity is L over T. And for right hand side, dimensions for acceleration and time using the table would be length over time square multiplied by time, which is length over time. And since the left hand side is equal to right hand side, this expression is dimensionally correct. Also, this equation only has single terms on both sides. But if there are multiple, we have to check each of the terms and they should have same dimensions. And that's all for this video. Thank you for watching.